Yeah. So I hope you can see the presentation.
Yes, sir.
Yeah, I'll just go through the things which I have covered in the last one or two classes because it will be continuation. Um, See, we were talking about earth pressure, and I have already rewind this revised things, and we have also talked about more circle and how to use more circle, like which is more pressure in the active, in the passive, in the at rest pressure. So at rest pressure, anything can be greater. Like sigma V is greater than sigma V is lesser than sigma H. But whereas in the active, sigma V will be the higher one always. That we have proved by this diagram. In the passive condition, sigma H will be highest always. And that sigma V, sigma H are principal stresses. That means the planes on those, these are acting, there will not be any shear stress. So by using this technique, these two techniques, we have found that active for active, um, so you can see for active sigma V is greater, for passive sigma H is greater. Okay. Then we have also discussed about, suppose the failure envelope and cohesion and friction angle, taking this diagram, I told you this is the equation which we can derive. Okay, where sigma 1 is this, sigma 3 is this. Okay, sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha. This is the equation which you can derive. Then alpha equal to 45 plus phi by 2, where alpha is phi by 2. So don't think that where from alpha has come from this diagram, as alpha is not there here. Alpha is nothing but just 45 plus phi by 2. It's, we have used one letter, that's it for this combination. So now in the active condition, we will get the same more circle, same failure envelope. The only thing is, in place of sigma 1, in the active condition, sigma v will come. In the place of sigma 3, sigma h will come in the active condition. In the passive condition, sigma h will come in place of sigma 1, sigma v will come in the place of sigma 3. So that's how we can write this formula. Last class you people have only told me, like in place of sigma 1 I have taken sigma v for the active condition and sigma h, like this. So now, um, what did I do? For active condition, I have derived this. I have taken for the active condition sigma h I need on the left side. See, these are effective stresses. You cannot use total stresses. So I want to find out sigma h dash at the end. For that, you need to bring h sigma h dash, this one, to the left. For that, I did this. See, this is the formula, initial formula. Then I found out what is sigma h dash by using, just by sending these terms to the left side. Then at the end, I got this. So I told you this. This is the major thing I told you about this. In place of tan square alpha, that means tan square 45 plus phi by 2, and if it is wherever it is there, you can just replace, just, so I'll just write this. Tan square alpha is nothing but tan square 45 plus phi by 2, right? It is nothing but 1 plus sine phi by 1 minus sine phi. So 1 by tan square alpha is nothing but 1 minus sine phi by 1 plus sine phi, isn't it? Yeah. Now it is just interchange. Now in this formula, it is 1 by tan square alpha, 1 by tan alpha. So I have taken 1 minus sin alpha by 1 plus sin alpha, 1 minus under root of this. So now I'll write this formula. Okay, this formula again here. What did we get at the end in the active condition? in the active condition, we have got sigma h dash equal to 1 minus sine alpha plus 1 plus sine alpha nahi, sine phi multiplied by sigma v dash minus 2c under root of 1 minus sine phi by 1 plus sine phi, right? This is what equation we have got for active to find out sigma h dash. Now, this term can be referred as make it as constant. Okay. Now I'll equate this to a constant. Okay, 1 plus sine phi. Okay. Now, as this is active condition, I'll give suffix Ka. This constant is nothing but coefficient of earth pressure. This is coefficient of active earth pressure. Sorry, this is active earth pressure. Okay. Now, how can you write this equation in the active condition? Sigma h dash is Ka multiplied by sigma v dash minus 2 into under root of Ka. Okay. Is there any doubt till here? So this is the equation to find out active earth pressure. Okay. Where Ka is 1 minus sine phi by 1 plus sine phi. If you are given phi value, then you can find out Ka, then you can use this. So now, this is for which kind of soils? Ka means phi, C means cohesion. For Ka, you need to have phi value and C here cohesion. It's C5 soil. C5 soil means it's not clayey soil, it's not just sandy soil. It both. Maybe clayey sand, sandy clay, okay, or silty sand, something like that, or sandy silt. Okay, both particles are there. It has both cohesion and friction angle. Just clay soil means friction angle will be 0. Just sandy soil means C value will be 0. C5 soil means clay sand or sandy clay. So like that. Both, it has both. That's how you will get both. Now, cohesion less is nothing but related to the sandy soils or coarse grained soils. Cohesion less. Cohesion less means C equal to 0. So for cohesion less soils or sandy soils, you can say sigma h dash is Ka multiplied by sigma v dash, right? Because C is 0 for cohesion less soil, right? That's how you will find out. And next, um, what you can do for passive, we'll just do for the passive. It is easy. We have the formula sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha, where sigma 1 dash is nothing but sigma h dash in passive condition, sigma 3 is sigma v dash, tan square alpha is nothing but tan square 45 plus phi by 2, okay, plus 2c tan 45 plus phi by 2, okay. Right now, see, we need to find out sigma h dash. That is what the earth pressure. So that should be left side. It is already left side because of the passive nature. So it is already no need to convert anything. So now I'll just write. See, tan square alpha we have already discussed. What is tan square 45 plus phi by 2 is nothing but 1 plus sine phi by 1 minus sine phi, right? Now, if 1 by tan square, then it would have been 1 minus, but it is directly this. We know this. Now, what can you write? Now, this one, this value, or so this parameter can be taken as constant k, let us say. So then sigma h dash is this is constant. Now I'm taking it as constant, k multiplied by sigma v dash plus 2c, again under root k. But this k and previous k, previously this k is 1 minus sin pi by 1 plus sin pi, and this is related to the active, that's why Ka. So every time Ka is nothing but coefficient of active earth pressure whose value is found out by doing this 1 minus sin phi by, but here I have taken constant 1 plus sin phi by sin minus 1 minus sin phi, so that as it is taken in the passive condition, passive for passive earth pressure formula, I'll use it as Kp. Okay, so where Kp is this. So now, what is the relation between K? So this is the formula to find out passive earth pressure, where Kp is this 1 plus sin phi by sin 1 sin phi. Now, what is the relation between K and Kp? Relation between Ka and Kp. Okay, what is that? It is easy that 1 by Kp, or Kp is 1 by Ka. That's it. So now you know how to find out Ka value. Now you know how to find out sigma v dash. We already discussed many times. Effective stress, it is nothing but gamma into gamma multiplied by h, like that. Then c is given in the in the question, so you can find out easily. Now this is for C5 soils. C5 soils. If it is cohesion less soils, you will be having only this. So I'll write here only cohesion less soils, active passive earth pressure is Kp multiplied by this one for cohesionless soils. So now you know how to find out sigma h values. Okay, we will solve one problem. Okay, by that you will understand clearly. Okay, uh, okay, I'll write. You also have to help me while solving this. Okay, this will definitely give you a lot of practice. These are very important problems. Problem number one. Okay, this is the question which I am writing. That is the question. Okay, so let us say this is retaining wall. Okay, so now there are two layers. This is the earth. Okay, there are two layers within this backfill. So that layers are divided. Let us say, so each layer has different properties. Now this is 3 meters. This is 4.5 meters. Okay, this friction angle phi1 30 degrees and gamma value 18 kilonewton per meter cube, whereas friction angle phi2 20 degrees. Okay, and gamma saturated value is given for this is 24 kilonewton per meter cube. Now there is water table here. So this is the water table symbol. Okay, this one, water table is there. That means it is fully saturated. There is water up to this layer. That's why these properties are different. Here there is no water. It's dry completely. Okay, that's why. That's why properties are different from here to here. Now I have to find out horizontal earth pressure at every depth. Okay, because sigma v changes from one depth to another depth, because sigma v is nothing but gamma into h. So because of that you will have diagram. Suppose if I have to draw roughly, okay, roughly if I have to draw sigma v diagram, sigma, sorry, it's very big. It's a rough diagram, right? Okay. So now if I have to draw sigma v prime diagram, whose is gamma multiplied by h. Just h is, it's like constant into sum. It's linear. So it varies like this. If this is h, it varies like this. At this point it is 0 because h is 0. At this point it is gamma multiplied by h. So it's a linear. This is sigma v diagram. Sigma v dash diagram. Okay. But whereas Ka if you multiply, or Kp if you multiply, what happens? This is also a constant. It's nothing but you will multiply here. Ka multiplied by gamma into h. So again one another constant came. That diagram also you will get linearly varying only. But their sizes are different. If this is 50, this is 50 multiplied by Ka. Okay, 0 is 0. So their triangle areas are different, but their shape more or less they are same. Now this is the just concept. Now we will enter into the main problem. Okay, this keep it. This is just a rough idea. Okay. Now we have to divide into layers, and we have to calculate according to the layers. Now anyway, we need here. What is the question? Question is about active earth pressure. You have to find out active earth pressure. Okay, for this question. So for that, for active earth pressure, what do you need? You need Ka value, right? Now Ka value, what is the formula for Ka value? Ka equal to 1 minus sine phi divided by 1 plus sine phi. This is the formula, and you need to calculate for finding earth pressure. So first let us find out Ka1. This is the layer 1, layer 2. Okay. Ka1 is 1 minus sine phi 1. Can somebody tell me what is the value immediately? 1, sorry, 1 plus sine phi 1. What is the Ka1 value? I'm expecting the answer within 15-20 seconds. Anybody? So if you are calculating, you can let me know that I can wait. Otherwise, I'll directly write the. I will calculate from my side.
0.33, sir.
Okay. 0.333. Right? This is Ka1 value. Can you tell me what is Ka2? You just take phi 2 instead of phi 1. Ka2 1 minus sine phi 2 by 1 plus sine phi 2. What is Ka2? It will be definitely less than 1 because
.5.
Point exactly, or because I also have 0.49, right?
Mhm.
Okay. So now you have two Ka values, two layers. Okay, but don't think that these two layers are separate. See, this layer is the top layer is resting upon the second layer. You cannot ignore that weight. See, gamma is nothing but from everywhere. You have to just sum up gamma 1 H1, then here gamma 1 H1 plus extra this one. So like that. So now we will enter into that calculation of the problem. So I'll just roughly again. Okay. Now layer 1, layer 2, Ka1.33, Ka2.49, then Phi is 30, gamma is 18, Phi is 20, gamma sat is 24 kilonewton per meter cube. Kilonewton per meter cube. Okay. So this is the things. Now this is top. I'll just give. This is top. This is 3 meter depth, right? This is 3 meter and this is 4.5 meter. So this is 3 meter and this is 7.5 meter, or you can say bottom. I'll give that names. Now, can somebody? I'll just what do you at top? At top, what now? We need to find out sigma h dash, which is equal to Ka multiplied by sigma v dash, as it is active pressure minus 2. This will also come, but the thing is, as it is cohesion less soil, because cohesion is not given, so C is 0. So in that case, this term gets cancelled and you will have only this. Okay, you will have only this. Now this at the top, I want to calculate sigma h dash. Okay, at the top, what is sigma v dash? First of all, at the top, at this point, can somebody tell me what is sigma dash value? Gamma multiplied by h. Can someone tell me what is sigma v dash at the top? These calculations are for the top.
Zero.
What?
So 0.
0. Why?
So it becomes height is 0.
Yes, it's 0. Sigma v is 0. So implies sigma h dash is also 0 because Ka multiplied by 0. So you have the value of sigma h dash 0 at this point because sigma v is 0 because h is 0. At this point h is 0. If you go down, then h will increase. So it is linearly increasing from the top. So sigma h dash is 0. That we understood from the top point. Then next we'll shift to uh, I'll try to at 3 meters. At 3 meters, there are two things. Okay, first let me calculate what is sigma v dash at 3 meters. Can somebody tell me gamma multiplied by, let me use that sigma I equal to 1 to n gamma I h I. Gamma I is nothing but, if it is not saturated soil, you have to take as it is. If it is saturated, you have to take gamma dash. So finally, that is nothing but gamma effective. Now tell me at 3 meters, what is the sigma V dash? These are layers. These are nothing but layers. I equal to 1 to n is nothing but layers. Suppose there are 3 layers above it. Each layer has different gamma and different h. Then gamma 1 into h1 plus gamma 2 into h2, different height that layer. So summation of all those 3 different layers you will get. So how many layers are there above 3, and how to take now? Can somebody tell me?
Only, only sir,
One layer. So what should I write now? Gamma into h. Which gamma I should take?
18. The gamma dry,
18. Gamma dry or gamma, just gamma 18 multiplied by,
3 height,
yeah, 3 height. So how much is it?
54. 54.
54. 54. See, this 18 is kilonewton per meter cube and this 3 is meter. So how much, what will I get? This is the kPa, is nothing but kPa. Now I got sigma v dash value. Okay, at that position 3. Now what should I find out? My thing is sigma h dash, but how will it vary at 3 meters itself? That I'll tell you, because at 3 meters there are two values. One value is having ka1, another value is having ka2. So it is changing, it's interchanging. Okay, weight will not decay. Somebody may ask me why you have taken 18, why not 24 at this point? Because above this point, this is the gamma value is 18. Due to that gamma, you will get the stress. You will not get any stress due to this bottom layer. Whereas now, when you are using K value, up from here to here, you will use one K value, that is fine. But from here to here, you have to use this K value, right? Because of that, at this point, you have to use two different K values. That's why what will I do is, I'll write at 10 and 3 meters only, just above. A, just above. Just above means just here only, but just above. Okay. Now, if I talk about that just above thing, sigma h dash will be, we know that Ka multiplied by sigma v dash. What is Ka? Just above Ka1, right? Ka1 is 0.33 multiplied by sigma v dash we have found out. So what is the value? This is 18 kPa. Sigma h dash is 18 kPa at 3 meters just above. Now what will I do? I'll calculate just below. Just below, when you go down, when you just go down from this point, okay, the vertical pressure is same, but that vertical pressure will be converted as horizontal pressure due to which factor? Due to this Ka factor. Okay, so just above the horizontal pressure is 18 kPa due to this Ka factor, but just below sigma h dash will be Ka2. This is Ka1, this is Ka2 sigma V dash. Sigma V dash will not change even at just below, just above, because it is still at the 3 meter. So Ka2 is how much? Ka2 value 0.49. 0.49 multiplied by sigma v dash is 54. What is the value? It is 26.46 kPa. Sigma h dash just below. Now at 3 meters only we found out. At top we found out that is 0. At 3 meters just above, just below we found out. Now you have to find out at bottom. So we'll again shift. Okay. Now I'll just roughly draw. Okay. Again, not to confuse. Okay, this is 3 meter. 4.5 meter and 3 meters. There is water table here. Gamma 18, phi 30. Saturate is gamma saturate is how much? 24, right? Yeah, gamma saturate is 24 kilonewton per meter cube. Kilonewton per meter cube. Phi is 30. So any other properties we are missing? No. Now we are calculating at the bottom. At the bottom, what is the uh, pressure? Okay. At the bottom, again you have to find out sigma v. Sigma v dash at bottom is nothing but I equal to 1 to n. These are layers. Gamma multiplied by height of that layer. Gamma I hi. Okay. So now you have to tell me this is good. Sigma at bottom. Can somebody tell me here? Just tell me, I will write. No need to give the answer directly. Anybody is telling me? You just have told gamma into h 18 into 3. 18 into 3. 3 is the height. In the same way, you can tell me here. It will be practice. If it is going wrong, don't worry. I'm not here cutting your marks or something. I'll just correct you. You will remember even more.
Sir, 18 into 3
Yes.
plus
Plus.
gamma submerged 24 minus 9.81
Okay. Let us take 10 because
10.
in the question it is 10. Okay.
Yes, sir.
Okay.
14, 14
Multiplied by
and 4.5.
4.5. So this is the sigma v at the rate bottom, right? So can you tell me 54 plus 14 into 14.5? How much? Totally how much it is? 14 fours are 14 fours are 56. So 14.57, then 62. Is it so? Or 63? Yeah.
So 117.
Okay. So this is sigma at bottom. Now you have got at the bottom. So is there anything to calculate just above, just below? This is already ground base. Okay, retaining wall is starting from here. Okay, is there any just below thing? No, because there is no other layer. It's just bed now, bedrock something, and there is no pressure coming from this soil onto this. Okay, onto this retaining wall. So we are stopping at this point. So there is nothing to calculate just below or to take another parameter. You just have to take one Ka value, that is Ka2, because this total pressure which is coming from the top to bottom completely, that is having pressure at this point, that is converted to this using only Ka2, not by Ka1. Okay. So every time, what is the procedure? Procedure is, first, at any step, you have to calculate sigma V first, then multiply by Ka of that layer. That's it. Now some people may say that Ka1 into sigma V1, then plus Ka2 into sigma V due to this layer. That is wrong. Okay. What you have to do? First you have to find out sigma V completely, just like this. Okay. Then if there are two layers, just above, just below, total sigma V is converted to sigma H due to Ka1 above this. If you go little below, the total sigma V1 will be converted to sigma H due to K2. Now here in the third one at bottom, if you talk about that, sigma H dash at bottom is Ka2 multiplied by sigma V dash at bottom. What is the Ka2 value? 0.49 multiplied by 117. How much is it? How much is it? 0.49 into 117.
57.33.
Yeah, 57.33. Now, is this problem over? Sigma H dash at bottom is 57.33 kPa. But here, if you see, is there any water above this? Above this, there is no water. Only below this, there is water. Now, whatever sigma V you have found out, that is final. Okay. And there is no pressure, extra pressure coming onto the retaining wall from water or anything. So you have used 54 to convert to sigma H at this depth. There is no issue. So at this depth, we know at 1.18, at 1.26.46. But when you are going down here, okay, water pressure, I'll just draw. Suppose retaining wall is here like this. So now there is water here. So you know what is the water pressure? What is the water pressure? Pore water pressure, sigma W is gamma W into H. That is what we were deducting. Pore water pressure. This is pore water pressure. That is what we were deducting. If you see, if there is any gamma sat, what we are doing? Sigma H dash. First we are calculating total gamma sat multiplied by H. Then we are doing gamma W into H. This is pore water pressure. PP. This is total pressure. Then this pore water pressure, then gamma sat minus, as H is common, multiplied by H. Then this is nothing but gamma submerged effective into H. That is how we are finding this. Sorry, sigma V dash it is. Sigma V dash. But what we were deducting first, pore water pressure. How to calculate pore water pressure? Like this. Okay? Like this. Now, now pore water pressure, if it is 0, this is 0 at any depth, suppose this is Z, then it will be gamma W into Z at this depth. So this is 0 at this top. Now pore water pressure here I will calculate. The water is starting from here. This is 4.5 meter, this one. So what is the pore water pressure? Pore water pressure is, it varies like this. where this is 10 multiplied by 4.5, that is 45 kPa of sigma W or pore water pressure is there here. Now somebody can ask me, anyway we found out submerged, that means effective we found out. From the effective we found out sigma H value. You cannot find out sigma H from the total pressure. You have to use only effective vertical stresses. Then you have to multiply by Ka so that you will get sigma H value. So finally we found out effective horizontal earth pressure. But why am I calculating this again? Okay, because if you know the Pascal's law, if you take any bowl, if you know the Pascal's law, at any point, the water pressure in every direction it is equal. That is called isotropic condition in the pressure. So this law where pressure is same in every direction at any point. For a particular point, if you consider the pressure is same in every direction. That is what the Pascal's law. From the Pascal's law, this water pressure generally we understand that it is vertical because it gravitational force. It's not just that. Coming to the water, in every direction it is same. So whatever pressure at this height, whatever pressure at this height, that pressure is not just vertical, it is also horizontal, also in this direction. Okay. Finally, this wall is not only be subjected to this effective horizontal pressure, which is coming from the effective vertical stresses, where we are neglecting the water. Okay, it's not only be subjected to that, it is also be subjected to, it is also is getting subjected to this water pressure which is horizontal, and that horizontal pressure also is same as that of vertical pressure. This is gamma W into Z. That is the reason why whenever you are asked to find out horizontal earth pressure, you should not forget about the water. Okay, after finding the effective horizontal earth pressure, you have to find out water pressure from that top of that groundwater table to the bottom, wherever it is. Then you have to add this triangle to the pressures which you have calculated. So now, after calculating what I am understanding at 3 meter depth, at 3 meter depth, pore water pressure is 0. But at bottom, what is the pore water pressure? That is 45 kPa. Now you have to add this top and bottom to which values? To this value, to this, and also this, right? Because both are at the 3 meters. 0, you have to add 0. Anyway, they are same. Now, when you add, when you add water pressure, what is happening? It is becoming total horizontal earth pressure. Coming to the earth pressure, you have to use total pressures because it's a wall. At the end, it is a wall. Wall is being subjected to this total pressure, which is coming from the soil as well as water. But when we are talking about the vertical stresses are between the soil particles, not something you are not going to carry there at one particular depth. If you are going there and if you want to carry, you have to carry water depth as well as the soil weight and water weight. So then total pressure coming comes into picture. But when we are talking about the vertical stresses, remember that it is only vertical effective stresses. But when we are talking about horizontal pressure that is coming on the wall, that is not just due to the soil, it is also due to the water. So now what will I do? At the top, at top it is 0 that we have calculated. At 3 meter, just above, just below, just above it is 18, I think so, and just below 26.40, 26.46 kPa. This is this much kPa, right? But these are what? sigma h dash, sigma h dash. You also have to add water to get total sigma h. So here total sigma h also 18 plus 0, 18 kPa, sigma h just below, just above is 26.46 plus 0, 26.46 kPa. Total sigma, these are total, these are effective, these are effective. Now at bottom there is only one value. That value is sigma h dash. We calculated how much? 57.33. Okay, kPa. But total sigma how much? 57.33 kPa plus 45 pore water pressure. Okay, right? Okay. How much is the value now? 57.33 plus 45. 102.3 kPa. So you know the values at every depth, and in between it is linearly varying because it is just a constant multiplied by that. So how can I draw the diagram? I'll just draw the diagram. Sigma V diagram also I'll draw. It is 0 at the top. Okay, and it is sigma V is 18. Yeah, sorry, 54. Sorry, 54. It's 54. 0 is 0, and sigma V at 3 meter is same. Just above, just below, it doesn't matter for the sigma V. And sigma V at the bottom is 117, right? It's 117. So this is the diagram of CV dash. So I'll draw sigma H now. Sigma H diagram. Sorry, total sigma, right? So at the top it is 0. Okay. At this point, how much? Just above 18, just below 26.46. So first it is 18. Okay. At the same depth, what is happening? From 18 to 26.46, it is changing. It is kPa actually. Okay. It is changing from here to here at that depth only due to the change in the parameters. Now at the bottom, how much? It is not just 57. It is not 57.33. It is 102.33. First 0 at the top, then at 3 meters, 18 and 26.46. Total you have to find out always. 18 and 26, and at the bottom it is 102.33. Okay. From here it is 102.33. So this is nothing but this one, this depth, this width. It is also kp. Now you have got sigma h diagram. So this is what, these are the pressure, this is the pressure. So if I ask you, this is the pressure, if I ask you to find out force from this pressure, what do you need? You have the pressure, you want to find out the force, total force. What do you need? So this is the this is 4.5, this is 300, this is 18, this is 26. Okay, this is 100. So now you have the pressure. but I need force. What do I
So
need?
area is needed.
You need area, right? Which area I need? Pressure into area. But which area I need? Generally, if I talk about, I have one pressure, but which area I have to take? So what will you tell? Area on which this pressure is
So
acting.
length
Correct?
into height.
Yeah. If it is triangle and if it is trapezoid, it's not about that. My question, okay, you may be right, but my question is that which area means if somebody asks, what you have to tell is the area on which this pressure is acting. That is the area. Now, if I talk about this pressure, where is it acting? Suppose this is retaining wall. Okay, this is the retaining wall. So this is the retaining wall. So this retaining wall is not like this, no, it is like 3D diagram. Okay, this stress is also acting at every point in the lengthwise. This is lengthwise. Okay, you are getting, I think you are understanding. Everywhere it is acting in this direction, right? Is there any doubt? So like this. Now what you have to do, this pressure I know. Suppose at one depth, at this depth, I know the pressure, okay, along the length. So what you have to take this area, this area you have to take, right? That area multiplied by this pressure, you will get the force. But here one point is this pressure is not uniform. At the top it is 0, at some point it is 18, it is triangular variation. The pressure is triangular variation. Then what you have to do, you have to take the average pressure over this area. So if I, just a minute, suppose if I draw the same diagram, this is the pressure diagram. This is the pressure diagram. This is 18, this is 26.46, this is 102.33, and this is 0. So there is wall here, there is wall. Okay, there is a pressure value, these are kps. Okay, now the wall is like this. You can take some area. Okay, this is the area on which this is acting, this is acting, and remaining bottom area is this one. But on this area you cannot take 18, you cannot take 0. What you have to take, you have to take average value, average pressure multiplied by this area. So now I don't know the length, I don't know the length. That's why what will I do, I will take length as 1, or what will I tell at the end, force per unit length. That means I don't bother about this length. That length is 1 meter only because length is not given. But I know the height. So length into height, length is 1 here because that is not given. So it's a per meter length. Length into height multiplied by which pressure? Which pressure you will take, because it is acting like this. This triangular pressure is acting on this area. Length into height. Which pressure you have to take, average pressure. How to take average pressure? 0 plus 18 by 2. Let us say 0 plus 18 by 2. Okay, then uh, L I will remove because L is 1 only. Now what are you understanding? Half multiplied by this half is from here multiplied by H. This is the force I am talking about. Force per unit length. Unit length equal to half multiplied by h into 0 plus 18 is 18, right? If you see this diagram, Where did I draw that? I'll just erase this. Okay. So now if I erase that, half into h is this into 18. It is nothing but triangular area. This triangle area. This triangle area, see this is the pressure diagram. If you take the area of the pressure diagram, that means you are getting the force, right? In the same way, now what is the average pressure? Average pressure is, so this is 26.46, this is 102 point. Let us say this is A, this is B. So what is the average pressure? A plus B by 2. A plus B by 2 is the average pressure. So on which it is acting is this height H2 multiplied by 1, multiplied by 1, H and 1. That is the area. This is the average pressure. For totally you are getting force. So this is 1 anyway, length. So it is nothing but if you see half into A plus B multiplied by H is nothing but what? Trapezium area. This trapezium area. So what are you understanding from this? Whenever you have to calculate the total force, you have to take the area of the pressure diagram. You found out the pressure diagram, that is sigma H diagram, not sigma H dash. It's a sigma H because you have included water pressure also everywhere. So now area of this sigma H diagram is nothing but FH force. Total force you can find out by calculating total area. So total force acting on this. So now what will I do? I know the pressure diagram. Pressure diagram is something like this, 26.46, and this is 18, this is 0. So what will I do? I don't calculate total force at a time. I'll calculate force 1 separately, force 2 separately. Force 1 is nothing but half multiplied by 3 meters. This is 3, this is 4.5, 3 multiplied by 18. And force 2 I'll do half 26 plus 26.46 plus 102.33 multiplied by 4.5. See, I know the forces now. Two forces. Total force is nothing but F1 plus F2. Okay. Now, people can ask what is the moment about the force about this point. Suppose this is the retaining wall. This is the retaining wall. What will happen to retaining wall? Retaining wall rotate it about this point. So what is the moment? Moment is nothing but force into distance. Force into distance. So total force from the area 1 is F1. I have calculated here. Total force from F2 I have calculated here. So how to calculate the moment? You calculate M1 and M2. M1 plus M2. That means force 1 into lever arm 1 plus force 2 into distance lever arm 2. How to calculate lever arm? So where will this force applied? It is at the CG. CG is 1 by 3 from the bottom, 2 by 3 from the height. So force will be acting like this. It's 1 by 3 H. This is 2 by 3 H. H is this, if this is H, this one. So like that you know the location of the force. In the same way, you can calculate the force position of this. Or else if you want to convert this force 2 also into into two other diagrams, you can make it rectangle, you can make it triangle. Okay, you can calculate this as force 2, this as force 3. This force will be applied at the center. Okay, in the middle exactly, because it is a rectangle. This force again will act at the 1 by 3 from the bottom. So like that, F1, F2, F3, you can find out forces. Area of this diagram will be the F2. Area of this diagram will be F3. Area of this diagram will be F1. You know the location of F, you know the total force, you can find out the movement about any point on this retaining wall. So that's how the calculation of earth pressures, earth forces, movement due to earth pressure at the bottom of the retaining wall. So you may be asked earth pressure at any location, you may be asked total force, horizontal force acted on the retaining wall. If you are asked to find out total force, you have to find out total earth pressure. You have to divide them into different areas, then take the total area is total force. So that's how this problem, and we may solve another problem in the coming class, this, and then we'll be done with the earth pressure. Okay, then I'll start uh, shallow foundations and deep foundations in the next class, next to next class. Is there any doubt? So it's 8:05 or 8:07. I've taken some extra time. It's no worries. Is there any doubt? So then I'm closing the session. We'll meet in the next class. Thank you, everyone.